بسم الله الرحمن الرحيم رب زدني علما.
Now, the next thing, we'll try to understand the different challenges you will be facing if you're using autonomous AP architecture. So before we move on to the lightweight, we need to understand the different limitations or the challenges we face. Now, one of the major issue is we have to manage each and every access point individually. So which means, let's say in my network, we do have maybe one or two access points. You're going to manage them individually. That's something you can do. But what if I have hundreds of access points, or just take 10 to 15 access points? Then the problem comes because you have to go to each and every access point, and you have to configure the SSID. You have to configure the security parameters. You have to configure the pre-shared keys to use for authentication. What will be the radio frequency channels to be used? So you need to configure all these parameters on each and every access point, which is something not efficient. So that is one of the main reasons we don't really prefer to use this architecture, this autonomous AP model. Now, one more issue is, let's say we configure the SSIDs. Let's say we configure the SSID, let's say for VLAN 10, and we have configured the SSID for VLAN 20, 30, and they are being mapped with a VLAN 10, VLAN 20, VLAN 30 on my wide network. So everything is working fine. But now the question is, what if I need to add a new VLAN? So we need to go to switches, add the new VLAN, and then we need to assign the ports. So of course, this is on the wide network. And on the wireless as well, we need to add a new SSID, let's say SSID, whatever, 40 number. And this has to be configured on each and every access point again. And also we need to configure the trunk links to carry that new VLAN as well. So this is going to be very difficult. Now the same thing applies. What if you want to remove any specific VLANs or modify any specific information? So this is one of the issues. So mapping is one problem. You need to map the specific SSIDs with the VLANs. And if you misconfigure the mappings, also there is a problem. And what if you need to add a new SSID or the new VLAN? Then again you need to go to each and every access point and do that. So that is one of the limitation we can say with this one. Now the other options are like upgrading the firmware, as each and every access point are managed individually. So if you want to upgrade the firmware is like just like improvements. You can say enhancements or the improvements in the next version, which was introduced by any hardware, let's say, like upgrading your operating system or updating your firmware. That's what we can say. Now, if this has to be done, this has to be done individually separate, because there is no centralized way to do. So you need to log into each and every access point, and we have to do it individually. So that is again one more limitation or one more challenge you will face. Now, same thing, authentication information. So we need to make sure that all the access points have the same SSID. That is one more thing you need to know, because you cannot say that SSIDs has to be configured on each and every, SSIDs has to be configured on each and every access point, but we need to make sure that they match the same SSID. If there is a mismatch of SSID also, that's not going to work. Now, apart from that, you also need to ensure that you are going to configure the authentication credentials, and these credentials must match on each and every device. So if there is any mismatch of these credentials also, you may not have proper connectivity to the wireless users. Now, additionally, one of the major challenge, as I said just now, is like misconfigurations, because we are going to configure every access point separately. So there is a possibility of misconfiguration of SSIDs, maybe typing errors, or maybe let's say the SSID is VLAN 10. Maybe here by mistake I have added VLAN 100, let's say. So there is a possibility, or maybe there are some security key misconfigurations, or sometimes VLAN to SSID mappings you do that may be wrong. So these are the problems. So there may be a mismatch of the configurations or misconfigurations. So both are like wrong configurations. And also there is a possibility that also there is something called frequently non-configurations. Now this comes when you add a new access point. Let's say in my network, I'm adding a new access point. Now I have configured everything here, and my users, the wireless users, are connecting to this access point. That is fine. But as this is a new access point, if this new access point is not properly linked or connected to the network, like the trunk link or SSID to VLAN mapping, if this is not properly done, so all your wireless user traffic will come and drop here, because it will not go beyond this point because of the because of the configurations which are not properly mapped or properly configured. So this is again one more problem with the autonomous AP architecture. Now one more challenge is like management is going to be very difficult because we are managing each and every access point individually. This can lead to some of the security vulnerability issues. Like a couple of examples, let's say if I go with, it may lead to something like each and every access point is going to handle the security policies separately. So whatever the security policies or security parameters, and this is not centralized, so which means there is a possibility of misconfigurations. And again, it's again the one more issue is any rogue access point can also get added into the network on its own. That can also one of the issue. So that's something we need to find out. So there is a possibility of a rogue access point being added or security parameters are not properly configured. That can be a problem again. Now one more issue is like the radio frequency RF signals, RF management, because each and every access point has to be, we need to set up each and every access point with a specific radio frequency parameters that has to be used for each access point, again based on the models. Like we need to decide whether we are going using 802.11a standard or 802.11b or m, what is the actual standard we'll be using. Again, what is the signal quality? We need to also define that, or transmitting power, because depending upon your coverage area, you need to decide the transmitting power of each wireless device, and also number of clients you are going to connect. So these are all kind of uh, radio frequency parameters you have to define on each and every access point. As we are doing individually, so there is no centralized option, it's going to be very difficult. Now one more issue again as monitoring, because intrusion prevention system, like there is something called IPS devices or intrusion prevention system. Now this is typically to monitor the traffic for any kind of vulnerabilities. As all the access points are managed individually, so most of the traffic, let's say if it is going within the access point, it goes directly, and there is no centralized traffic flow. So as there is no centralized traffic flow, because the traffic may go from here this way depending upon the VLANs, but whereas in case of centralized we use WLC, the traffic will go through the WLC. So as there is no centralized traffic flow, it's very difficult to monitor the traffic like intrusion prevention system, or if you want to apply some quality of service for a specific traffic, like giving priority for specific traffic like VoIP, or reserving some kind of bandwidth, these options are not possible yet. So it's very difficult, we can say. So like bandwidth policing, restricting the bandwidth for specific traffic. So these are something, this is going to be very difficult in general. So to overcome all these things, you always want some kind of centralized management, and that is where we'll be using centralized architecture or lightweight access point architecture, which is the next one we'll be discussing. So most of the typical production networks will be using centralized WLCs, which will be used to manage all the access points from a single centralized location.